All right, so again, today we're focused on elimination and combination methods. So elimination / combination method. And I'll zoom out here in a minute because I think I'm way too close to this. Yep. Full paper. All right, there we are. So, elimination and combination method. Again, it's the same thing. And just like I mentioned yesterday, we're first going to talk about when this is best used. So, best used when equations are in the same format. Now, a lot of times they'll be in standard form. So, best used when equations are in the same format. So I'm going to put in parentheses here, standard form, because a lot of times, if you have equations that are in standard form, this is an easy method to go to right away. I feel like that's just not focusing. Does that look blurry to you guys up there, slightly? Maybe a little bit better. Okay, anyway. The other time that it is best used is if the two equations have opposite values for one of the variables. If two equations have opposite values of, or I should say for one of the variables. For one of the variables. So, that's when it's best used. Now, what are the actual steps that we're going to take when doing this? So, the first two steps I'm going to kind of just glance over because in order to get to use this method, again, you want one of these two things to be true. But you can also make these things happen in order to use this. So the first two steps are basically getting it into the format that we need it to be in order to use elimination or combination. So the first step that I'm going to give you guys is get equations in the same format. So get equations in the same format. Second of all, we want them to have opposite values, meaning additive inverse. You guys remember the idea of additive inverse? What does it mean to be additive inverses? So if I said positive 2, what's the additive inverse of positive 2? Negative 2. Yeah, so again, it's just one's positive, one's negative. They're opposites, right? Inverse means opposite. And when we talk about additive inverse, it's the difference between having a positive and a negative of the same value. So, make one set of variables additive inverses So example there, positive 2, negative 2. And the way you do that is through multiplication. Through multiplication. All right. So if you don't already have additive inverses, then we're going to have to multiply by something to get them to be additive inverses. All right, so now this next step is where we're really starting our method here. So you're going to add the two equations together to get one of the variables to cancel out. Add the two equations together to get one of the variables to cancel out. So once you're down to one variable, you're going to solve for the remaining variable. And finally, take that first answer and plug it back into the original equation and solve for the second. Just like we said yesterday. Once you know one of the answers, then it's just a matter of plugging it back in and solving for that second piece. So I'm writing the same exact step that I did yesterday for this last part. Take first answer and plug it back in to the original equations. Now, I'm saying equations, again, you really only have to plug it into one of the two equations and solve for the other variable. All right, so those are the basic steps. So, again, I think we have at least enough time to do two examples right now. So we're going to take a look at two examples. There is a third example I'd like to do, but I don't think we'll have enough time to do it today. So, example 1 for elimination and combination method. All right, so I'm giving you guys a system, and it is 3c minus 4d equals 8. And the second equation, 2c plus 4d equals 12. Now, looking at what we already have here, are these in the same format? Yeah, these are already in the same format. Do we have additive inverses? Yeah. So the d's are additive inverses of one another. We have a positive 4d and negative 4d. So right now we can go straight to step 3. We're going to add these together to get one of the variables to cancel out. Because if we go ahead and add those two together, that now gives us, so adding these entire things, 3c and 2c is 5c. Negative 4 and positive 4, well, that's 0. So that did what? It canceled out, right? Because you don't need that 0. And then 8 and 12 give us 20. So the reason why this is called either elimination or combination method is because we are combining two equations together through addition so that we're getting one of the variables to eliminate. All right, so again, it's called elimination method or combination method. It's the same thing. Yes. So now, once you have only one variable left, so now this equation is just 5c equals 20. What's the last step to get c by itself? Divide. So divide both sides by 5, and c is 4. Now, are we completely done? No. Because this is just one part of our answer. We have C. We don't have D yet. So we need to also find D. So we got to take that answer, plug it back in, and solve. Does it matter which one you plug back in for? No. It's whichever one you think's easier. Now, if one of them has smaller numbers, I'd probably go with the one that has smaller numbers. If they're about the same, like on these, this one has bigger numbers on this side, but smaller number there. This one has smaller numbers on this side, but bigger number there. Does it really matter which one we do? No. I'm just going to go ahead and use the bottom one this time. So bringing that part over and combining that with what we just did down there. So again, I'm taking this original equation of 2c, which is now 4, plus 4d, and it's still equal to 12. So again, I used the bottom equation. Could you have used the top one? Yeah. Again, you'll get the same answer either way. So I used the bottom one. Again, it didn't really matter. So now, simplifying this. 2 times 4 is? 8. So we have 8 plus 4d equals 12. Our next step would be to do what? Minus the 8 on both sides. Good. So we have 4d is equal to? And finally, divide. Yeah, divide the 4. So d is 1. So we have an answer for C, and we have an answer for D. Now, this was not an X and a Y. So can we really write this as a coordinate anymore? No. So we won't do the order pair anymore. We're not going to write this in parentheses like we've been doing. All right. A lot of times when we're getting the equations in this format, where we have them in standard form, they won't always be X's and Y's. So I'm trying to stay away from the X's and Y's in these examples because a lot of times we'll be using these to do like a word problem. We'll come up with some equations. You'll usually have other variables besides X and Y, and then you'll solve by elimination or combination method. All right. Now, that's the first example. There's another example I want to do today, and it's going to start off slightly different. So example 2 for this. We have A plus 2B is equal to 3. And then we have 2A minus 5B is equal to 6. Sorry, not 6. I looked at the wrong part. 12. It's equal to 12. So now, are they in the same format? Well, A's there, B's are there, and set equal to a constant. So yeah, they're in the same format, but do we have additive inverses? Do we have opposites? No, no opposites this time. Now, you could do this one of two ways. All right, we have the B values, one's a positive, one's a negative. So the closest number that they share in common, the 2 and the 5, is 10. But in order to get these to become 10, I have to multiply both equations. I don't really want to multiply both if I don't have to. So let's look at the A values. Here I have 2A. Here I just have A. Well, I could get this to become negative 2A if I multiply the top equation by what number? So this is positive 2A down here. In order for this to be opposite, it'd have to be negative 2A. So I'm going to multiply this top equation by negative 2. I'm multiplying the entire top equation. Now, the way I'm showing this really isn't proper notation, but again, I'm just trying to show that I'm multiplying everything on top by negative 2. Every term on both sides of my equal sign. Really, if I wanted to be proper, I'd put parentheses around this side, times it by negative 2, parentheses around this side, times by negative 2. But again, you get the idea there, right? So, rewriting this equation. Negative 2 times A is negative 2A. Negative 2 times 2B is negative 4B. Negative 2 times 3 is negative 6. Now, we still have the same second equation. So that part I did not change. Now they're in the same format, and we have additive inverses. So now if we add these two together, what's going to happen to those A values? They're going to cancel. It's 0A, so they cancel. If you don't want to write the 0A, you could just cancel it off like I did there. That works too. On these, we add those two, and we get negative 9B. These two we add together, and we get positive. Now, this one might not be as nice as... some of the other problems because our final answer here is going to be a fraction. Because now the last step would be to divide by that negative 9. And when we divide by that negative 9, we get negative, and we're going to simplify this fraction. What goes into both 6 and 9? 3. So divide 6 by 3, you get 2. Divide 9 by 3, you get 3. So our first part of our answer is negative 2/3. Again, we're not done yet because we only have one of our two parts of our answer. We have B. We still have to go and get A. Doesn't matter which equation we use. No. In fact, we could use the original equation up at the top. We could use this equation, or we could use the one that was altered there. Any one of those will give us the correct answer at this point. So you got to take this and plug it back into one of those originals. Again, you can do whichever one you want. I think the top one looks slightly easier. So I'm going to use that top equation there before I had actually multiplied. And again, I'm going to plug that B value in. So I'm using the original equation. So A plus 2 times negative 2/3 equals 3. Now, again, it makes it look harder because we have a fraction in there, right? But we dealt with a fraction yesterday. It wasn't that bad. So on here, we're going to start off the same way. We're going to multiply this out. 2 times 2/3. Now, the only problem is 3 is not divisible by 2. So when we multiply this, we don't get a whole number yet. So we're going to have A plus, actually, will it be plus anymore? No, because we had a positive and a negative. So that's going to become negative. 2 times 2 is 4. We still have the 3 on the bottom. So not very pretty. If we move this over now, we have to worry about adding a fraction with a whole number, and I'd rather not get into all that. So an easier way to solve from this point, get rid of the fraction. Multiply the whole thing by 3. Again, if you want to pack up and go, you can. I'm going to finish this one little step here because we're almost done. So multiply everything by 3 to get rid of that fraction. You'd have 3A minus 4, because the 3's would cancel out, equals 12. And then it's just a matter of adding 4 and dividing by 3. I did make one mistake. I made one mistake. I just realized. 3 times 3 is not 12. That's 9. So our final answer there should be 13. And divide by 3. And that's our final answer. 13 over 3. All right. Again, I'll throw this up.